In this video, I'm going to be talking about converting moles. Some things we have to know before we start converting moles. First off, Avogadro's number. For every 1 mole, you have 6.022 times 10 to the 23rd atoms, or molecules, or particles. It could be anything. So we're going to take advantage of that conversion when we have to convert from atoms, or when we're given moles, or to moles when we're given atoms. Also, if you're given grams, you have to convert to moles first, and then you can convert to atoms. So if you have a problem that starts with the grams and they're asking for atoms or molecules, you have to go to moles first, and vice versa. If you're given a problem where you have to start with atoms and they ask for grams, well, then you're going to have to convert to moles first. The masses we're going to use come right from the periodic table. For example, hydrogen on the periodic table just says 1.01 under the symbol for hydrogen. That means it has 1.01 grams for hydrogen. And for every 1 mole of hydrogen, it's 1.01 grams of hydrogen. It's a molar amount. So when we look here on the periodic table and you see hydrogen, there it is. That's the mass we're going to use. So what that means is that that number, grams of hydrogen, that's equal to 1 mole amount of hydrogen. So if you were to measure out 1.01 grams somehow of hydrogen, you would have exactly 1 mole of hydrogen. Now we can also equate that to Avogadro's number. So that amount of hydrogen, that many grams, is equal to this many atoms. So you would know when you have that measured amount, you have this many atoms on that container, or in that container. So the first one we're going to do is moles to grams. So we're given 13 moles of aluminum. What is the mass in grams? Well, for every 1 mole of aluminum, according to the periodic table, we have 26.9 grams of aluminum. Again, that's also equal to Avogadro's number. This is equal to 6.022 times 10 to the 23rd atoms. But we don't need that here. All we need is this conversion right here. So we're given 13 moles, and we need to go to grams. So we're going to put grams on top, grams of aluminum. And we'll put moles of aluminum on the bottom so they cancel out. And we have 26.9 grams. So all you're really doing is 13 times 26.9. 349.7 grams of aluminum are in 13 moles of aluminum. And that's a lot. Next is grams to moles. So we're going to use a similar conversion factor. In this case, we have carbon dioxide. So this isn't just one compound, this is several compounds. So first we have to find the mass of carbon dioxide. So that's CO2, so that's carbon, which is a mass of 12, 2 oxygens, that's 16, another 16, that's a total of 44. So carbon dioxide, we add up each individual element, it's a total of 44 grams of carbon dioxide. And that's equal to 1 mole. So 44 grams of CO2 is equal to 1 mole of CO2. And that's also equal to Avogadro's number. So when you measure out that much CO2, that's 6.022 times 10 to the 23rd atoms of CO2. It's just in this case, again, we don't need that. We don't need that conversion. So we got our 7.24 grams of carbon dioxide. And in this case, we need to go to moles. So I'm going to put moles on top. So for every 1 mole of CO2, we have 44 grams of CO2. So when you set it up like this, the great thing about it is that you can see how grams cancel out, and your new unit is going to be in moles. So the math is very simple, but setting it up like this way lets you see, okay, after I do the numbers, I'm going to have the units of moles of CO2. This will be more helpful in a second. So now we're going from atoms to moles to grams. So Avogadro's number. So 1 mole is this many atoms. For every 1 mole, in this case, we're dealing with calcium. So for every 1 mole of calcium, it's this many atoms. If you look in the periodic table, the mass of calcium is about 40 grams. So for every 40 grams of calcium, that's 1 mole, that's this many atoms, Avogadro's number. So in this case, we have 7.35 times 10 to the 25th atoms. Of calcium. So what is the mass in grams? So we are going to go from atoms that were given to moles, and then we'll convert those moles to grams. I'm going to set it all up first. So first I have to go to moles, so for every 1 mole of calcium, and I want to get rid of atoms. So I got to put atoms in the bottom, or Avogadro's number on the bottom. Because that is the conversion factor, for every 1 mole of anything, it's Avogadro's number. The next part, you have to go from moles to grams. So I need to put grams on top. Grams of calcium. So for every 1 mole of calcium, we have 40 grams of calcium. So the math of it is quite simple. You divide out Avogadro's number, and then you just multiply that by 40. So all we're going to get is 4,882.1 grams of calcium, and in proper scientific notation, it's 4.88 times 10 to the 3rd grams of calcium. So this will be our final answer. Last one, grams to moles to atoms. So we're going to do the exact opposite. In this case, we have magnesium fluoride. So you want to find the mass of magnesium fluoride first. Like before, we had just one individual element. Here we have a compound. So first, mass of magnesium fluoride. So magnesium fluoride is MgCl. Or actually, I believe it's MgCl2. Yeah, it's MgCl2. So magnesium is 24.3. We got 2 fluorines. Total mass for this whole compound is about 95.3 grams for every 1 mole. So 95.3 grams of MgCl2 for every 1 mole of MgCl2 is equal to Avogadro's number of atoms of MgCl2. So in this case, we have 97 grams of MgCl2, magnesium fluoride, and they're asking us how many molecules or atoms. Again, we got to deal with Avogadro's number here. First, we got to convert to moles. So I'm going to put moles on top, since that's what I need to get. So for every 1 mole of MgCl2, and I want to get rid of this mass in grams, so 97 grams of MgCl2. Then after that, you can convert from moles. For every 1 mole, you have Avogadro's number of atoms or molecules, whatever, same thing. So again, the math is pretty straightforward. It's just setting it up so you can see how the units work out. And that gives us 9.77 times 10 to the 23rd atoms. Oh no, actually that's not right. That is the proper math is so same, so it comes out actually to 6.1 times 10 to the 23rd atoms of MgCl2.